Recently, I was given an opportunity to once again implement a age calculator in a project that I was working on. And though I've been lucky enough to implement that calculation many times in my life, it was the first time that I had an opportunity to implement it in Kotlin. And one of the things that I was struck by was just how elegant the solution looked in Kotlin compared to the other times I've had to implement it in other languages. And that's mainly thanks to the use of Kotlin extension functions. In fact, I was so impressed with the way that it looked that I created a blog post about it, which you can visit on my hbrown.dev URL, and I've also created this video to show you what I found. And in the process, just to make life a little bit interesting, I'll also show you how I tested that age calculator. So to start off with, I've created a Gradle project. It's a bog standard Gradle project with nothing in it. Well, that's not true. It's got this JUnit platform.properties file, which just specified that the tests that I want to write in here should have a single instance lifecycle, and that means that I won't get a new instance for every single test method that I write, which is something I recommend you do for all Kotlin projects if you're not already doing it. Okay, so to start off with, let's just define some of the dependencies that we're going to need, and I'll walk you through those dependencies that I'm going to add in. So the first dependencies I'm going to add in is just one for JUnit itself and version 5.7.1, and then strict, which if you haven't used it before is an assertion library, which I quite like, so you can check them out on strict.io. And then this dependency, this file pick dependency, is just required by strict itself. Okay, so those are all the dependencies that I need, and then next I'm just going to define some of the Kotlin compiler options. I just want to specify that I'm targeting Java 11 and then set it up to run the JUnit 5 tests. So let's give IntelliJ an opportunity to import everything over here, and I think that all looks good. So I've got my test source and my main source set up and two empty packages in there and nothing else. So let's get started with that. So I'm going to start by kind of just writing the test that I started off with. And these are all going to be in an extensions file. So I'll just call this class extensions test. Okay, and the first thing I want to do is to basically just create a test method in JUnit 5, and let's call it should be able to calculate the age from a local date. Okay, and we'll get the ball rolling on that. Okay, so the first thing I want to do is I basically want to have a local date, and then I want to call a method on that local date, and then I want it to return the age in years. So it should look something like this. If I go val date of birth equals local date dot of, and I give it some year. Let's make this first one simple. So we go with 2021, and we'll set the month as the first, and we'll set the date as the first as well. So given a date like this, I want to be able to say the age in years should be the date of birth dot get age in years. Of course, the Java type local data has no idea what that means, so it's really unhappy with me, but we'll go with that for now. And then I want to expect that my age in years is equal to 0, and then I just want to ask IntelliJ to help me out with the imports. Okay, so that's basically the first first test that I want to be able to write. So in order to make that work, I'm going to head over here and I'm going to create a Kotlin class and call that extensions, because I want to write this as a bunch of extensions and I can actually just get rid of that. Okay, so to create a Kotlin extension function, we use the fun keyword as usual. We specify the type that we want to add our extension function on, and we give it a name, get age in years, and we specify the return type, which in this case is int, and let's import that type. Okay, and then for the actual implementation, the first part, I'm going to make this really simple. I'm simply going to say to calculate the age, I want a chrono unit, and I want to use the years, that's correct, and I want to say give me the years between whatever it was called on and also local date dot now. I think that should be fine. What is it unhappy about? Oh, right, I've got to obviously return an int. Okay, so let's just move this down a little bit. Okay, so there we go. So we've now got this get age in years. We've created it as an extension function. I can access whatever instance of local date this was called in by using the this keyword, and the calculation is complete. So if I head back over to this now, I just need to import that, and then we can attempt to run this code. Okay, and it looked like everything was happy, and that makes me happy. So we probably want to test this with some more interesting dates than just the 1st of the 1st, 2021. We probably want to see some corner cases, such as if it's the day before birthday or the day after birthday, are we actually calculating the date of birth correctly? In order to do that, we probably want to swap out this test with a parameterized test so that we can pass in different pieces of data and essentially run the same test over and over, just with different data. To do that, I like to create a Kotlin data object and use that as my argument type. If I override the toString nicely, then I get a nice output for my test as well. So rather than you watching me type all that out, what I'm going to do is I'm just going to copy and paste that data object in here, and there's nothing too exciting that's going on there. But essentially I specify data object with the date of birth and the expected age in years, and I override toString to give me a nice output. Okay, so now that I've got that as a data object to use in my test, I can now go and amend this test, and what I'm going to do first is I'm going to accept this as just as an argument and call that date of birth age pair, and then I'm going to break this down using a destructured declaration, which is my date of birth, which is of type local date, and I also want the age in years, or the expected age in years, which is an int, and that is going to be destructured from the argument that gets passed in. Okay, so then I don't need these two things anymore, because those two things will get passed in over there, and then all I've got to basically do is that I've got to expect that the date of birth that I get in, if I call get age in years on that, then that is going to be equal to the age in years that I expected. And of course, what I've also got to do is I've got to get rid of this test annotation and change that to a parameterized test, and then I need to define a source from where I'm going to get all of this data. So in this case, I want to use a method source, and I'm going to call that method source local date to age, and then I'm going to pretend like I typed all of that out, and that will basically be all of my interesting examples that I find interesting. Okay, and then IntelliJ is telling me I can remove that as a qualifier, and that should be enough to get this test going. So if I run that test, I can see that I get the output over here. It's not the nicest output, and one of the things I can do to make that better is I can specify some kind of string over here that JUnit will use as the string when it outputs this. So I can say, please give me the index in the brackets over there, and I can ask for the only argument that I'm passing in, which is 0, and I want to use a fixed date, right? Because at the moment I've got no idea as these dates change. I have no idea if these tests will continue to pass. They may pass today, but if I run this code in another 6 months, then I've got no idea if that would still pass, because obviously my implementation of this uses the local date.now, which gets the current date, but over time that will change, and so suddenly I have really brittle tests which might fail for no other reason, not because the code is wrong, but simply because the date has changed. So one of the things that I can do is I can use a system clock to allow me to specify the date. So I can use another feature from Kotlin, which is default argument. So I've now said that my getAge in years can accept a clock, and if none is provided, it will simply use the system clock, and I can then use that clock when I create a brand new date. Okay, so this allows me now from production code to use it in the way that I did before, but from my test I can now control how this date gets created. So if I head back into my test class, then I want to be able to specify a fixed date. So the way I like to do that is to use something called a fixed clock. Instead of typing all of that, I'm just going to paste that out over there. So what this does is it basically it creates a clock which always specifies the date as the 21st of the 3rd, 2021. Okay, and then I can also use that as a variable because it's a constant. I can also use that as a variable inside of my name over here. So now that I've fixed that, I can pass that fixed clock into my function getAge in years, and that will essentially use this clock as the basis for calculating age. And that way I can be certain that the age does not, or that the test that passes today will still pass in another 6 months or another year's time. So if I run that, what I'll notice is that I also get a nicer output, or I think it's a nicer output for each of my tests, and I also don't have to worry that these tests have become brittle in any way and that they will suddenly stop working. And that probably is enough, but there is one other test that I also like to perform, which is basically a test which says that if I pass in a date in the future, I should not get a negative test or a negative age back for that test. And of course, this isn't going to work with the current implementation. So if I try and look at this at the moment, it will just always give me back a integer value, whether that integer value is positive or negative. So in order to fix that, I've got to update this implementation over here, and I'll just paste it in and then we can have a look at it. So essentially we use the if statement to determine if the date passed in is after the current date determined by the clock that was passed in, and if it is after that date, then it's a date from the future, and we return or throw an exception which says that it's an invalid date of birth. Otherwise we perform the calculation as we did before, and I've just defined a runtime exception to make life a bit easier. And now that I've done all of that, I now have a test that tests that, and if I run all the tests, then we should be in a situation where we can see that all the tests have passed, and I know that they will continue to pass even as time passes. Thank you very much for watching this video. Just a reminder that if you want all the source code for this video, you can head over to my blog, and at the bottom there's a link to my GitHub page which has all the source code for this example over there. Thank you very much.